Hello and welcome to another tutorial. We are looking at the control flow statements in Java, and we looked at the if statement, and now we're going to look at the if else statement. And if else means that we have the if with its condition, and it has a scope which defines the body of the if, which means all the codes in this scope are going to be associated with when the condition is true. Else also has a scope, or basically multiple lines of code that are inside a pair of curly braces. And the else happens obviously when the if condition is not true, and if it's not true, then the body of the if is not executed, but the body of the else is going to be executed. So that's very simple meaning of the else statement. The if else statement provides a secondary path of execution. Now in the if, we saw that if the condition was false, we just continue with the rest of the code. But here, if for the if else, if the condition is false, then we still jump to the else statement and execute it, right? So it provides a secondary path of execution when an if clause evaluates to false. You could use an if else statement in the this method apply brakes method to take some action if the brakes are applied when the bicycle is not in motion. In this case, the action is to simply print an error message saying that the bicycle has already stopped, right? So we're using the error stream system.err ERR instead of system.out. Remember, out means it's the console output, it's the regular output. Error means it's the error stream, and then usually this still prints to the console, but it prints it to the console into when using the error stream. If you're not familiar how the console works in Unix based operating systems such as Mac OS and Linux, they usually have the standard output has usually two output streams. One is the standard output, which you output to the console. The other one is error stream or error output. It still prints to the console, but prints it using the error stream instead of the output stream. The following program, if else, assigns a grade based on the value of a test score: an A for a score of 90% or above, a B for a score of 80% or above, and so on. And by the way, we saw that the ternary operator that Java provides, it's exactly similar to an if else statement, right? The bytecode, we saw that the bytecode was pretty much the same. And usually when we have only one statement for the if clause and one statement for the else clause, usually it makes also sense to use the ternary operator, right? That makes the code a little bit more readable if you want to use the ternary operator. And as I mentioned before in the previous lectures, one of the use cases of the ternary operator for me is to quickly check if a object reference is null, and it is. If it is, I assign a default value to it. Now these days they recommend to use the optional class, which is a generic class or a parameterized class to avoid null pointer exceptions, this kind of stuff. But you can also use the ternary operator to check a reference if is null, and if it is null, you just go ahead and assign a default value to it. Now here, as you can see in the main method, we have these two variables, right? One of them is, so these two are local variables. One of them is initialized, and we said that in the previous lectures that the local variables are not initialized to the default value by JVM. So before using them, or basically you can assign, you don't need to initialize them if you want to assign to them, right? But if you don't assign anything to them and try to read the value from an uninitialized local variable, the compiler gives you an error. So this is not a runtime error, this is a compile time error. That's because it's not safe, right? So Java wants to avoid the pitfalls that C++ has in terms of reading garbage values from memory. Because even in C++, it's still safe to read from a uninitialized variable because it just holds an garbage value. But then in Java, they decided not to allow it at all. So unless you initialize it with some value, you're not allowed to read it, right? So if you comment this part out, you get a compilation error because you're reading something that is not allowed. Now I can basically show you quickly. Let me just copy this and go back to the let's create a new class, if else clause, and let's have a main method here. So I'm going to create public static void test1, and I'm going to copy and paste this whole text. And obviously I can say Command Shift F to auto format it. It's already formatted by Eclipse nicely, and we're going to execute test1, which is a static method. Now this compiles fine, and obviously I can also run it, right? And it says grade equals C, right? Now if I comment this part out, I get a compilation error, and you probably can guess what the compilation error is. It says that the local variable grade, you declared it, so we declared it here, but you never initialized it, which means you can initialize it as soon as you declare it, or later on you can assign some value to it. These two are both allowed, but if you don't assign any value to it and don't initialize it when you declare it, then it's not safe, right? I mean, you can still read values from it, but it has a garbage value, and Java compiler decided not to allow it. So it says that the local variable grade may not have been initialized, which is true, right? So you can either initialize when you declare the variable, or you can you can declare it and then later you can assign a value to it. As long as it holds a valid value, it doesn't hold the garbage value, the Java compiler is okay, right? All right, so if else statement, note that the thing about if else is that some people think that else if is a keyword or a new construct, which is not. In Java it's not. So this is basically one if else, and then else has another if. So after else you can put another branch, right? So else if is not a new keyword in Java or even in C++. So I'm going to write it down here. Basically else if is not a new keyword or construct in Java or even in C++. What this means is that I can say if, and then this is my condition. I have a scope or a body for my if, right? And then else, and then create a new scope and put everything in this, right? And then put a new basically if inside, and this still works. So this whole thing is the scope. Let me format this. So this whole thing is the code that gets executed when the if clause, if body is not executed, we go in the else. So there is no such thing as if else or else if, right? Because else here I have a scope for the else, and then I put more branches, more if branches into it. So else if is not a new keyword or construct. It's just else, and inside else we can have if, right? And we said that if you have only one line of code or one statement after if you or else, you don't need to use a body. That's why after the else we can quickly use if without any curly braces, because this whole thing becomes or basically this whole if becomes one statement. Remember we said that one line of code of if becomes one statement, and after else, if you have only one statement, you don't need to use braces. But again, else if is not a new keyword or some new construct, right? It's just if else, and inside the if you can have more if and else, right? All right, so the output is grade C. You may have noticed that the value of test score can satisfy more than one expression in the compound statements, right? And the way the if else gets executed, we look at the first condition. If it's not satisfied, we go to the next one, else if, right? If it's not satisfied, we go to the next one, and if it's not satisfied, so the very first condition that satisfies, we execute it and then we jump out. So the rest are not satisfied. So that's another thing about if else. If else if is that only the first condition that is satisfied is going to be executed, or I can say only the first branch that is associated with the condition that is satisfied is going to be executed, right? What this means is that you may say, okay, this test score 76, and then we have this basically condition greater than 70 is satisfied, greater than 60 is also satisfied. But then we only we start from the top and go down. This is not satisfied, this is not satisfied, this is satisfied. So we go into the body of this part, and then after we execute it, we jump out of the entire if-else construct, right? Which means that even if this condition was satisfied, we never look at the rest. That's one of the things about the if-else, which means that if this is satisfied, do it and then jump out of the entire construct. Don't look at the other conditions. That's the meaning of if-else, right? Again, later we see that there is another construct in Java called switch expression or switch construct. Switch has a little bit, is very similar to if else, but it has something called fall through, which means that the first condition that is satisfied, we execute it, but if you don't have a break out of it, so that you have to manually break out of switch. Otherwise, fall through happens, and then other conditions or other statements that relate to other conditions will actually get executed. But if else statement is not the case, right? For the if else statement, only the first condition that is true is executed. The rest of the conditions will never be executed, and then we jump out of the entire if else, right? We will look at the switch statement or switch construct in the future lectures. So this was the main basically conditional branches, if else, and next obviously we have the loops, repeating something. The main purpose of loops is repeating. But before that, what I would like to show you is what happens in the bytecode for the if else statement. We saw that in the if what we do is basically we just compare in the bytecode, we compare the condition, which is a bool type, and it's in the bytecode is 0 or 1, right? We compare it with 0, and then we decide whether we go into the rest of the if or jump out. So public static void test2. Alright, so let's go back in our if clause, and we saw that we had a condition here, and we declared as a final, and it's an integer literal expression. So this whole thing will be evaluated by the Java compiler at compile time. And then we said that let's put one expression here. So if condition, we're going to print a statement 1, else. Again, as long as we have one statement or one line that terminates with semicolon, it's one statement. We don't need to use a pair of curly braces, but that's recommended. That's the best practice, to always declare the scope. Let's sys out a statement 2, and this is the else, this is the if part, right? Note that at runtime we're not going to evaluate the condition. Basically at compile time, this whole thing will be either this one or that one. That's the reason. The main reason is this condition is final, and the right hand side is a literal expression. So this gets evaluated by the compiler. And then because this condition variable is final, the compiler knows that its value never changes. So it knows that it's either true always or false. So the compiler knows that one of these two branches will be always evaluated. The other one will never be evaluated, right? All right, test2. Let's run this. And as you can see, if and then if I say 5 greater than 30, we execute the else statement. And to prove to you that in the bytecode this else never happens, let me run this again. Let's go back to the if else and then open it with the class file, the compiler, look at the bytecode, and we're going to look at the test2 here, right? And what you see here is that iConst1, integer constant 1, it means a boolean true, which is the result of evaluating this literal. And then I store 0 at the index 0 of the stack, basically store an integer which is named condition. And what is the value is going to be stored? The last value on the stack, or the last value that was loaded, which is 1. It means that just load true in the condition, right? Condition is always true. At compile time, it has been evaluated true. And then get a static print line. So we are jumping. There is no if statement. There is no comparing this condition, right? Load a statement 1 if. So you see that at compile time in the bytecode, the compiler realizes that this branch will always get evaluated. As soon as I remove this final keyword, now this test2 becomes much longer. Now we go to the condition. So 2 bytecodes for this line of code. We're going to say iconst1, which is the result of evaluating this expression, and then we're going to store it into the store. And then so this will get evaluated by the compiler, and then the result is true. We store it in the condition, and then we go to if statement, and here we have to, because this wasn't final, the runtime, right? The JVM has to check the value again. That's why we load the value of the condition again, and then we decide what to do, right? And then we say that if equal, jump to line bytecode 17. So if equal, which means if this value that we just loaded is equal to 0, which means if it's false, jump to 17, which means we're jumping here. Get a static print line and load a constant expression, which is a string, a statement to else, and then invoke the virtual, invoke the method, invoke this print line method, right? So basically what happens is, instead of checking for the true value, we actually check in the bytecode, we decide based on the false value. So decide based on the false value, which means we compare to 0, which means check if condition if false. In the source code we say check if the condition is true. Logically it makes more sense to check if it's true, like for a human being, but for the machine it's easier to compare just with 0. So based on the false value, right? All right. Otherwise we just get the out field and then load this statement 1 if, and then we print it and then go to the 25. 25 is just return, right? So as you can see, we use the go to bytecode expression to say that when this is when this branch executes, don't do anything with the else part, just jump to the outside, right? Outside is whatever code that comes after the entire if else construct. That's the main idea, right? So if we go into the else, we never look at, if we go into the if, we never look at the else. Now the question that you might be asking is that, if that's the case, what if we have a compilation error in the else block? Does it matter if we jump to the if? And the answer is yes. The Java compiler still gives you a compilation error. So let's say, for example, we say that int x equals 10 long, because we cannot implicitly convert long to int. You see the compiler gives me a compilation error, right? Even if the condition is going to be true and we never jump to the else, still we get a compilation error. Now what happens if we say final? So we still have this compilation error, and you know that in the final case, in the actual bytecode, we never write the code of the else part. That's the beauty of this final keyword. In the bytecode, we never write any code related to the else block, because the compiler realizes that only this branch of if is going to be executed. But still, if we have a compilation error in the else block, the compiler refuses to compile, right? That's just because it makes more sense this way. The code is safer and nicer, and Java is all about safety and readability, this kind of stuff, right? So this was the full introduction to the if-else statements, and To recap, we saw that the else if is not a new keyword, a new construct. The only construct is if else, and in the body of the else you can have more ifs. So that's why you sometimes see this else if. You don't need to have to write the else and if on the same line. You can even put a pair of curly braces between else and if, as we did here. You can put one here and then put here. So the idea is that in the scope of the else, you can have more if else, right? And it doesn't mean that the else if is a new keyword. It is not. Now in programming languages like Python, there is a specific keyword for else if. So it's called elif. So elif is a new keyword. So you say if, elif, and eventually else, right? So elif is a new keyword, but in Java, else if is not a new keyword. You only have if and else. And inside the else, you can have more if and else, right? So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.